So one thing that makes the trig functions a little easier to evaluate is has to do with something called the cofunction identities. So you've probably heard before that angles that add up to 90 degrees are called complementary angles. Two positive angles are called complements if their sum is 90 degrees. So when you have a right triangle, the two acute angles in the right triangle are automatically complementary angles. Okay. All right. So when you have a pair of trig functions for which f at theta is equal to g at 90 degrees minus theta, those trig functions are called cofunctions. Okay. So let me give you an example just based on this picture. Let's say that I was trying to find the sine of theta, from this picture. Switch over to draw. Okay. So the sine of theta would be the opposite over the hypotenuse. The opposite is a, little a, and the hypotenuse is c. Then let's say for some reason I was trying to find the cosine of the complementary angle 90 degrees minus theta. The cosine is the adjacent over the hypotenuse. So with respect to the angle 90 degrees minus theta, the adjacent is a, right? And so it turns out that the cosine of 90 degrees minus theta will also be a over c. And that's the way it always works for cofunctions. The value of the function at an angle will always equal the value of the cofunction at the complementary angle. So let's see how that looks when we have it all written down. Okay, here it is right here. The value of a trigonometric function of theta is equal to the cofunction of the complement of theta. So now it turns out that the cofunction pairs are very easy to remember. You take a trig function that does not have a co in front of it, like cosine, cotangent, cosecant. The cofunction, you get it just by adding co in front. So the cofunction of sine is cosine. The cofunction of tangent is cotangent. The cofunction of secant is cosecant. So these identities are really very, very easy to remember. The sine of theta is equal to the cosine of 90 degrees minus theta. I showed you that on the previous slide. The tangent of theta will be the cotangent of 90 degrees minus theta, et cetera, et cetera, et cetera. And then if you start with a function that has co in front of it, to find the cofunction, you just take the co off. All right, so the cofunction of cosine is sine, the cofunction of cotangent is tangent. And of course, if we're measuring theta in radians, use pi over 2 instead of 90 degrees. All right, so an example, actually two examples of using the cofunction identities. They want me to find a cofunction that has the same value as the given expression. So the first given expression is sine of 46 degrees. Sine of 46 degrees. All right, so when they say find a cofunction with the same value, they mean write the cofunction. So of course for sine, that's cosine. And then plug in the complementary angle. So you're not going to put 46 degrees. That's not going to be the same thing as the cosine of 46 degrees, but it will be the same thing as the cosine of, oh, I never wrote these in. I guess we'll have to do it now. I could have sworn I did that. Okay. Well, let me back up. This will be an I do one, you do one. Okay. All right. So what they're looking for sine of 46 degrees, they're looking for me to say that that's the same thing as the cosine of the complementary angle 90 minus 46. So they're looking for me to say that the sine of 46 degrees is exactly the same thing as the cosine of 44 degrees. Okay. All right. So the next one is going to be the cotangent of pi over 12. So if you're watching the video, I'm going to ask you to pause the video and try to figure out the cofunction for cotangent of pi over 12. Notice that pi over 12 is in radians. Okay, and we'll compare notes when you're finished. All right, so the cotangent of pi over 12, of course, the cofunction for cotangent is tangent, and we're doing this in radians. So instead of subtracting that angle from 90 degrees, we have to subtract it from pi over 2. And so that's going to look like this. So you replace cotangent with tangent, and then replace pi over 12 with the complement of pi over 12, which would be pi over 2 minus pi over 12. Multiply the top and the bottom by 6. That gives you 6 pi over 12 minus pi over 12 is the tangent of 5 pi over 12. All right, a little bit of vocabulary that we'll be using, maybe not in the very next example, but definitely in the future, is angles of elevation and angles of depression. So imagine that you're standing on this 3rd floor balcony here, and you look out and you see an airplane and you see a car, all right? Since the airplane is above you, if you needed to measure that angle going up for some reason, we call that an angle of elevation because it's going up. And similarly, if you were doing something with the car and you wanted to measure your angle to the car, we call that an angle of depression because it's going down. Okay. So again, those terms will come up in the future. I don't think they come up in the very next example, but let's look at the very next example. Okay, so this business with right triangles, right triangle trigonometry comes in really handy for this kind of problem. So the irregular blue shape in the figure represents a lake. The distance across the lake A, which you see right here, is unknown. To find that distance, a surveyor took the measurements shown in the figure. So he or she measured from this point all the way over to here, figured out that that was 750 yards. And then the angle from there to the other side of the lake is 24 degrees. Okay. So that is enough information to figure out the distance across the lake. And I'm just wondering if I did the same thing that I did with the other problem. I have a feeling I did. Nope, I didn't. Good, 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 good. Okay. So the way that you set that up, remember the tangent is the opposite over the adjacent. Okay, so with respect to this 24-degree angle, the opposite is A and the adjacent is 750. Now, so you might ask, well, how did you know to use tangent? And that's a really important question. So typically in a problem like this, there will be an unknown side and a side that's given. Let me say it this way, a side that's given and a side that you're actually trying to find, all right? So take those two sides and figure out if they are opposite and hypotenuse, adjacent and hypotenuse, or opposite and adjacent, and whichever one of those it is will tell you whether to use sine, cosine, or tangent. So in this case, we're trying to find the opposite, and we're given the adjacent. So to tie opposite and adjacent together, you use tangent. Okay. The tangent is the opposite over the adjacent, so that'll be A divided by 750. And then to solve for A, of course, I am going to multiply both sides by 750. Okay, I seem to always have a problem whenever I start with a multiplication dot. It thinks that I'm trying to click, and then the pen doesn't work. So I'm multiplying both sides by 750. And that gives me what you see on the next line. So that goes away and that goes away. That leaves me with A equals 750 times tangent 24 degrees. Okay, so I have to figure out 750 times the tangent of 24 degrees. Let me just make sure I am in degree mode. I am not in degree mode. I need to switch to degree mode. Okay, and now I'm going to ask the calculator what is 750 times the tangent of 24 degrees. As long as you are in degree mode, you don't have to put like a degree symbol or anything. You can just put tangent 24. And it comes up with 333.9215 something something. So that's how they got A is approximately 333.9 yards. They've rounded it to 1 decimal place.